So in addition to offering bean configuration for Java, Spring additionally offers a very nice library called Spring MVC. Spring MVC allows you to create a directory structure for your web applications, a dynamic directory structure in which you no longer have to manually parse out request parameters and path variables. And it's very simple to use. So let's go ahead and get started. If you want to make a class, you call it a controller in Spring MVC, and we can just simply annotate this with @risk controller. And then within our controller, we're going to have methods that get called whenever the web server gets hit. And for each method, we're going to tell it when you should call this method. So, for example, @request mapping with a slash, anytime we hit the base root application, it's going to say, welcome to spellchecker.com. Very simple. Let's launch this and see how it works. Now this application is using Spring Boot. Spring Boot allows us to launch a Java web application using an embedded Tomcat or Jetty server. I highly recommend it. It also includes all of the necessary Spring MVC framework jars that you'll need to get started. Okay, we can see that this port started up on 8085. Great. Welcome to spellchecker.com. Very simple example, but let's progress down the list and become more complicated. So in addition, we can say, hey, I want this method to get called anytime we say /words. So if we say spellchecker.com /words, now we're going to return this string. And we can make these as nested as we want. We can make it as nested as we like, as long as they don't conflict. And you'll notice that I'm actually commenting out each method as I go through, and that's because I want to build upon the complexity of the method. Because down here I've got more methods that respond to /words, but they've got a little extra thrown on them. And so as long as your URLs don't conflict, as long as you don't have two methods that can get called for a single path, you're money. So this is nice, but you're probably not going to have a separate method for every single path in your application. In fact, that wouldn't be very dry. We would be repeating ourselves quite a bit. So instead of creating a method for every single path, what we can do is we can create a dynamic path. In this case, we want to create a RESTful path. So now we say anything that comes in at spellchecker.com /words. Now we can pick off whatever comes after /words. We can say, and we can call it a variable called brand. And so we can pass an inheritance. And we can say this path variable right here. Actually, let's make that word. This path variable named word is going to equal this variable that we pass into this method. Very nice, but we can do more. We can do a lot more. In fact, oftentimes in RESTful frameworks, you'll want to include optional request parameters. For example, if you're searching through a collection of items, /words gives you the entire list of items, whereas if you wanted to search for words that rhyme with orange, you would have to include a request parameter. And it's very simple to do that as well. In fact, in the method signature, we just say @request_param, and we're going to look for a request parameter called rhyme with. And we're going to say, hey, you don't have to include this if you don't want to. So we could call /words, or we could call /words with rhyme with orphic. So polymorphic would get returned. And this again gets passed into this method as a variable. So this method will get called anytime we call /words, including if we say /words question mark rhyme with orphic. And then in that case, we would want to return all the words that rhyme with orphic. And probably best of all is that we have specific ways that we're able to handle errors and exceptions. So if something goes wrong inside your application, even if it's something that you know might go wrong, like let's say we try and look up a word that doesn't exist, what would happen then? Because the application is definitely in a bad state. Well, we know correct Java semantics says we should throw an exception. So in this example, what we're able to do is we're able to throw an exception, and whenever we throw that exception, this method's going to get called. So we say /words, and we're going to give it a request parameter that doesn't exist. We're not going to give it rhyme with. And in that case, we're going to say, hey, this is no good. And so we can throw this not found error. And this not found error is just right down here. And whenever we throw this error, after it leaves this method when we throw this error, now this exception handler that we've annotated with this exception name gets called. Now we can handle it any way we like. We can send it to a separate error page, or we can return the correct HTTP request header, response header. Okay, this is all very good. This is all very simplistic, but probably the biggest thing that you can do in Spring MVC, and I'll just touch on it now, is the ability to do RESTful frameworks and templating. And so oftentimes in RESTful frameworks, you're not just going to be passing back and forth strings. You're going to be passing back and forth entire objects, and you're going to be passing back and forth lists of objects. And so the tricky thing is, how do you take a object and turn it into JSON? And how do you take JSON and turn it into an object? Fortunately, there's a library called Jackson that does all of this automatically, and it does it all based on the naming scheme of your object. So, for example, in this beer class, it's going to send an object across the wire with beer, with a name attribute, with an attribute called name, and an attribute called type. It's going to do all the conversion for us. All we have to say is response body and request body. So we can pass stuff, pass a beer over the wire, we can pass a beer back, and it does all the conversion for us. We're always working in Java code, and we're never having to parse any strings at all.